I'll be showing you what RAG is and how we are going to use RAG in the AI world. So basically, RAG stands for Retrieval Augmented Generation. So it's a technique that lets an AI agent retrieve information from documents. So basically, the documents can be something like PDF documents in the private or internet documents which are used, and this that information which was retrieved from the RAG will be used by the LLM to answer our questions. Let me explain you more with an example here. So from this diagram on the screen, so if you consider LLM as a brain, so the RAG can be simply defined as brain plus some books. Like the books are nothing but here I'm referring to the documents. So the private or internal documents. If you consider this LLM as a brain, it was trained for all the it was trained with the data training data until a cutoff date, right? It knows everything it was trained on up to that point and nothing after that point. For example, now let's imagine your company has an internal document, and it is only accessible by your company HR. LLM has this AI LLM has no access to that document at all. So now let's say you ask a question to the LLM, what's the leave policy, or like what is the work from home policy for our company? So it has no access to that document, and it will start hallucinating, and it will start searching on the web, and it will come up with some wrong answers. Like it try to make up that answer, but it's not 100% correct. So it has no exact information to answer that question. So yeah, because it was not trained for that data, it has no access to that data. So I can explain you the same scenario with some other example. Let's say you are attending an exam. You are prepared for that exam until the night before that exam. So until last night, you are fully prepared for that exam. So now, if you're sitting in the exam and you have the answer sheet in front of you, and now the exam can be two types, right? Like one is closed book exam and open book exam. So if you're writing a open book exam, you try to remember the answers, or you try to form the answers from your knowledge that you have obtained from your last nights, or like until last night, what we call training, right? You are prepared for it, right? On the other side, like if you are like, for example, if you are attending an open book exam, so in that case you are trained for that exam, and also you have an open book beside you. So you have two resources here. One is open book, and also you're trained for that exam. So open book exam is more convenient for you, because you're going to give most 100% accurate answers, because you have trained knowledge as well as the open book, from where you can access the answer. Like you can go to that particular page and you can get that answer. So RAG is nothing but, like, it is also an open book. It can also be considered as an open book exam in the same way. So I hope these two examples gave you some context of what RAG is. Let's move on to the architecture of RAG. So before we move on to the architecture of RAG, like, to make it more interesting, let me show you one demo. So it's a simple demo. Basically, I'm giving a prompt here. What is the tax percentage for a person with a spouse and a kid? Before I do this, I have to show you this document here. For this demo, I'm using a PDF document here, like, which is shown on my screen now. So this is like 142 pages PDF. It's a 2025 tax returns, federal tax guide, like how to. It gives the information about tax system for the year 2025, right? I'm using this document. Now I'm asking a question of related to that document. So if you see, the moment I asked this question and I said, okay, use RAG skill for this answering this question, it went through some iterations, and it looped through that document, and it came up with some answer here, right? It came up with some answer. It looks very simple, and you might ask me a question now: why you are making it complicated? Like, you can just give the Claude Code the access to that particular PDF file. So you can just say, okay, this PDF file is sitting in my local directory in so and so folder. Go and access that. Go and access that file and answer this question. So yeah, that's very simple and straightforward. The Claude Code, the LLM can access that and just answer your question. But the main thing is, let's say if you are if giving the right direct access to that PDF, it will take, let's say it takes 200k tokens to read that complete document, right? But if you go through that RAG architecture route, so it might take only 2k tokens. So about 120k time, oh sorry, 120 times lesser number of tokens consumed when you're going with the RAG architecture. So basically, RAG takes smarter approach. Instead of giving the LLM the whole document, where you only give the relevant pieces. So I'll show you more in detail how the RAG architecture works here. Let me go to this PDF back again. So here, this is there are two systems here working in the background. One is the retrieval system, and the one is the generation system. So the retrieval system is basically, it brings the facts from that document, and the generation is where the LLM generates the answer from the retrieved facts. So these two these two systems partnership is the whole game here. Like, that's the main process behind the scenes. Let me show you another picture here. Okay, so this is the first step in this RAG architecture. So the first step is basically the RAG architecture converts that PDF documents into chunks. So let me go back to this document again. So you're seeing this 142 pages of document, right? So basically each paragraph or like each n number of lines will be converted into chunks. Chunks means like a chunk of text, right? In this example, this 142 pages PDF document is converted into 866 chunks. So, okay, so there are various chunking strategies. So for example, one mechanism can use chunk by size, or one can use by paragraphs, or one can chunk by semantic meaning, and so on. So there are various types of chunking terminologies. You can choose whatever you fit for your use case. So now what you need to understand here is this whole document is chunked into, or divided into 865 chunks. Chunks are nothing but the same document. It got converted into smaller chunks, right? So the next step in this RAG architecture is embeddings. So each chunk is now converted into embeddings. Embeddings, to give you some context about embeddings, an embedding is numerical representation of each, right, each chunk text. So each chunk gets converted into a long list of numbers called vectors that capture the meaning of that text. Basically, the chunks with similar meaning end up with similar numbers. And just like chunking, there are various embedding models and approaches to choose from depending on your use case. So basically, the next step in this RAG architecture is after chunking is embedding. So all this, as I mentioned, like this document was converted into 866 chunks, right? So now each chunk is converted into embeddings. Like embeddings are nothing but they're converted into some number format, long number formats. After this, like, so now every chunk has been converted into embeddings, which brings you this third step in the picture. Like now everything is chunked and then converted into embeddings, and now it should be saved in a vectored database. So for example, there are other a lot of other vectored databases. Like there are some other storage systems other than Oracle, but as I'm Oracle guy, like right from the beginning, I'm going with Oracle here. But if you are in the Oracle ecosystem, Oracle 26 AI has built-in vector embeddings, and vector search are one of its core features. So here I'm on the older version of Oracle, but if you are with the Oracle 26 AI, that makes your life very easy with this vectorization of these embeddings. I hope you understood the three steps in this flag architecture, right? So this picture will show you the exact thing. So first thing is we have the document, and it gets chunked into individual chunks, and then the chunks are converted into embeddings. That's ends where with that we are done with the three steps of RAG architecture, right? So coming to the other side, this is on the one side. Coming to the other side, for example, now you asked a question to the LLM. Okay, here this is my question, right? In this case, this is my question. What is the tax percentage for person with spouse and one kid? So this is my question. Even this question will be converted into tokens and as embeddings. Then this tokens will be converted into query embeddings. So now you have the document embeddings and also the query embeddings. There is a terminology called cosine matching. So cosine matching, it compares both the embeddings, and it comes up with the top 5 matching what we call matching chunks. So both the embeddings are compared. They will be done some they will be taken through some cosine matching, and the top 5 chunks, like which are with the highest score, are given to the LLM. So now for the question which I have asked here, so that for that question, this entire RAG architecture, instead of going through the entire document, it brings out of the 866 chunks, it brings only the relevant matching chunks, so that it is not providing the entire document to the LLM. It is just providing the top 5 matching chunks to the LLM. And that's a complete RAG flow. And you can see this on my screen now. So this is how a RAG architecture works. So the document converted into embeddings, question converted into embeddings, and both are cosine matched, and the top matching highest score chunks are provided to the LLM. So this is how the RAG architecture works. So instead of the one basic thing is, instead of looping through that entire PDF again and again, the LLM will be given only a few matched pieces of text. So now let's talk about the efficiency here. If we talk about the efficiency, if I give the direct access of that PDF to the LLM, let's say it consumes 240 tokens, 40K tokens. And if I go with the RAG approach here, it might go with only 2K tokens. So it is 120 times fewer tokens, right? That's the main efficiency comparison. So 120 times fewer tokens per question. So it's dramatically more efficient and faster and cheaper. So, and finally, let me highlight the security benefits as well. Here, coming to the security, this document, after chunking and converted into vectors, it is all in our database. So like if you are from Oracle or the DB background, you know how secure is the data in the database, right? You have the grants, privileges, and all on top of it. So that's where our data lives, and we are not giving the control direct access to the LLM. So what the LLM sees, only minimal egress, right? Only few retrieval snippets. These are the two main security advantages, security and data governance advantages here. And the second one is, the other advantage is it's completely built fully locally. No internet dependency, no external API keys required, etc. Right? So these are the main three advantages here. Now let me show you one more picture here. Now, if you ask me how did you build this, so now you can implement the entire RAG architecture using Python or PLSQL. I've always been a PLSQL guy, I built this entirely using PLSQL. So what you're seeing on my screen are the tables that I have created: RAG chunks, RAG chunk TF, and terms chunks, stopwords, etc. And this is where everything lives, like the chunks, embeddings, and vectors, like all the concept which I have discussed earlier. I built a package called RAG Engine. So it contains all the functions and procedures and power the pipeline, like chunking the document, generation and searching for the embeddings, retrieval of the relevant chunks. So the entire architecture end to end runs in the database. So one thing I think worth mentioning here is, like, I think I built this entire thing in the older version of Oracle, which means I had to implement all the vectorizations and such logic myself, like custom implementation. So if you are on the latest version of Oracle, like 26 AI, your life gets much easier. Vector embeddings and vector search are built in database natively, and so a lot of what I hand built comes out of the box in the latest 26 AI. I won't go deeper into this table structure. Instead, let me leave you with the key takeaways here. I'm repeating the key takeaways here again. First thing is, RAG is open book, not a closed book. The LLM answer from your retrieved document, not from its trained memory. That's what eliminates the hallucination on the private data. Second thing is, RAG is two systems working together, like retrieval and generation. Retrieval finds the facts, generation writes the answers. Third is efficiency. We have already discussed about like 240K tokens versus 2K tokens, like 120 times fewer times cheaper and fewer tokens. So, and the fourth advantage is it's secure. I already mentioned it. Your data never leaves the database except for a few small snippets protected by the role grants, adding your security here. So that's RAG entirely. And I'll show you one more thing. And you may ask me what are the where this RAG can be applied, right? Why it matters. And so basically, RAG is the foundation of nearly every serious enterprise AI application. For example, at your company, like you're working on a support bot which answers a lot of support tickets. So even in that use case, you might need a RAG working in the background, right? So, and if you are building some other knowledge assistants, AI knowledge assistants like runbooks or SOPs in plain language and etc. So even this use case, in this use case, you might need a RAG. Legal and contract document analysis, like even this, you need a RAG to securely give access to LM to securely access your documents. So that is all about RAG. And the one which I showed you is purely built in PLSQL on Oracle. And thanks everyone.